cart's crystallized, that's kind of the enemy. What's worse than having pure THC left in your cart when you're finished and not being able to access it because it's in a solid form, it's not liquid?
Yeah, exactly. So, you know, carts are ultimately a convenience item and also relatively expensive. And so if it's inconvenient to use or you're leaving a lot behind, so you'll let these crystals grow and then you'll spin them out to be able to, you know, draw the liquids off them essentially.
Sounds like the separation technique is really the way to go.
Yeah, absolutely.
No brainer. Want an unfair advantage in your live resin production?
Yes, please.
In this video, we'll help you discover the key to unlocking the full potential of your live resin production. We'll open the door to superior quality in your carts and other live resin products. We'll talk about how to expand your production capacity, optimize product manufacturing so you can deliver your products faster. The key here is THCa crystallization. These new processes are setting the standard for how live resin is produced commercially. So if you're ready for a future of profitability and excellence, then stay tuned for the rest of this video. We're here with the Chief Technology Officer at Genome Technologies, Lyndon Noble.
Hey.
Lyndon, what are some of the current ways live resin carts are being manufactured in a commercial setting?
Yeah, so I'd say there's three main ways that people are doing this process. The first way that people are doing this process is they will, perform the cold extraction. They'll take their crude and they'll do a pressurized decarboxylation. What that means is they put their live resin crude into a reaction vessel that can be heated and pressurized, and they heat it up to perform the decarboxylation reaction, but they keep it pressurized to keep that terpene fraction intact.
So usually they're adding like what we may call like a nitrogen blanket.
Yep.
And maybe using even like a vessel like a diamond mine or something that's commonly found in these labs.
Yeah, that's right. Yeah, you'll often add an inert gas or just use the CO2 as it builds up from the decarboxylation, but essentially you're just trying to prevent those terpenes from off-gassing while you do that process. The second way that people are doing it is sometimes you can actually prevent the crystallization in the carts by just adding distillate or THC back into your cart. So you'll take a live resin run that would otherwise have crystallized, and you can add enough THC to prevent that crystallization.
So they take distillate and just reformulate with distillate.
Yeah, exactly.
So, but that's kind of a partial decarboxylated cart, right? So you've got some combination of THCa, THC, and then terpenes.
Yeah, exactly. And so there's a repeatability and a reliability, concern there that you're not going to have, with different live resin varieties and from different strains and whatnot, you might have unpredictable results.
So batch to batch, you've got to come up with your formula every single time.
And also test it, and then also, face the issue where you might have a recall because you have a whole bunch of crystallized carts.
So, I mean, crystallized carts is one potential concern, but also if you reformulate it and it's a little bit more runny than a previous batch, potentially you could have leak issues, all sorts of kind of concerns could be coming up there.
Yeah, exactly. You just lose a lot of control with that process.
What's the third way that people are doing this process?
Yeah, so the third way that we kind of think is one of the best ways is actually to perform an initial crystallization to separate the THCa from your high terpene extract fraction, your live resin, and then decarboxylate your THCa separately and then recombine the two. And we think that that's more desirable for a number of reasons. We'll talk about that more later in the video.
So what are the important things that the consumer wants from their live resin product?
Yeah, I think that the consumer wants, they obviously want a good flavor profile. They want a unique experience, which could come down to minor cannabinoids and strain specifics and whatnot. But also just from, a functional perspective, they want a cart that is reliable, it doesn't leak, it doesn't crystallize, and something that they can consume all the way until it's finished.
Yeah, they don't want any wasted bits at the end there.
Yeah.
And also they're looking for an experience, like you said, that kind of stands out from a very monotone distillate cart. That's what I hear a lot from consumers, is that they find like a distillate cart that's just been had some flavoring added to it is a very mundane type of experience. It doesn't have any character.
Yeah, that's exactly it. Distillate doesn't really give you strain specific effects, which is obviously one of the desirable parts of live resin specifically.
And then having having carts crystallize, that's kind of the enemy. Because what's worse than having pure THC left in your cart when you're finished and not being able to access it because it's in a solid form, it's not liquid.
Yeah, exactly. So carts are ultimately a convenience item and also relatively expensive. And so if it's inconvenient to use or you're leaving a lot behind, you're not going to be providing as much value as you can for your clients.
What are the major challenges that commercial live resin producers experience in their operations?
I think the first thing that comes to mind is just logistically, when you're dealing with frozen biomass that can't thaw out throughout the process, you have the challenge of receiving a frozen product, keeping it frozen, and then getting it in and out of the machine without it thawing.
Absolutely. I think another big challenge is like the output of a live resin run, like a great yield, is around like 3%. And that's due to the fact that dry biomass might yield 18%, 20%, but that's because all the water's been removed. And so that you can fit way more actual resin in the form of, in the plant matter into the extractor at a time. And so, the challenge to me is just being able to do your runs way faster. That, if you want to produce live resin commercially, you need to be able to extract at 2 to 3 times the rate just to be able to kind of keep up when you're comparing to cured resin extraction.
Yeah, that's right. You end up running a lot more columns when you're running live resin to get the same amount of THCa output.
Any other challenges that you can think?
Yeah, another thing that can be challenging is, when you're dealing with cold butane and propane mixes, you'll often have ice blockages, and that issue becomes a lot worse when you're introducing a lot of water into the process. And
right.
Butane absorbs 1.5% by its weight of water while you're doing an extraction, and so you can very easily bring that water through the process and then end up freezing something up, and that can be a challenge.
Little ice block in your solvent tank.
Yeah, and especially in coils and pre-chilling coils and whatnot, those can be challenging, and that's why we move more and more towards larger heat exchangers, like plate exchangers and whatnot, that are a little less susceptible to that.
On the flip side, the converse side to the low yield issue that we talked about, the yield that you are producing is like incredibly high in terpenes. And that's really, to me, the reason why you're running the live resin extraction is because those terpenes have been preserved in the freezing process. You're getting as accurate of a reflection as you can possibly get of the plant, the way it was when it was growing, and the chemical composition that existed before you harvested it. And so to me, what you're really trying to optimize for in the live resin extraction is you're trying to optimize for that terpene fraction. And one of the benefits of using crystallization, we'll talk about a little bit later, is that you're able to separate that terpene fraction and preserve it and isolate it for potentially use as a formulation tool.
Yeah, exactly. When you talk about terpene retention in live resin, there's kind of 2 components to it. One is that it's a much higher value product because of those unique terpenes that are true to the strain and the work that the grower has done. But also with that amount of terpene fraction, you can kind of extend your batches if you're able to separate those products, and you have a lot more control over how much value you can pull out of one extraction.
I think the other thing that comes to mind is heat, and just the live resin process is a very low temperature process because of the frozen material, but also you want to minimize the exposure of heat to your terpenes, and so being able to separate them also allows you to treat them a little bit more carefully.
Yeah, right. Like the decarboxylation process it has to be hot, right? And terpenes, you've especially with live resin, you've expended a lot of effort in keeping them cold, and so separating the two and doing those processes separately is,
it's optimal.
Yeah, it's optimal.
So I think we touched on this a little bit, but what are the key advantages of using crystallization techniques when you're running live resin extractions?
Yeah, I think first and foremost, you get a lot more control over your product line and your production processes when you're able to separate those 2 ingredients.
Run me through how you can optimize your production processes by separating your extraction into ingredients.
Yeah, so if your extraction team is always going to be separating the HTE from the THCa and forming these 2 ingredients, then they're kind of doing the same thing every day.
It's repeatable.
Yeah, it's repeatable, and they don't need to be making decisions based on what is selling in the market or what the strain is going to be doing. They're just going to crystallize everything to take a high terpene fraction and a THCa fraction that can then be recombined by somebody in formulations, as opposed to trying to make those decisions in the production process. When your production crew comes in, their goal is to run as many columns as possible, keep their temperatures cold, and then perform a crystallization, as opposed to, okay, are we making diamonds in sauce? Are we trying to make shatter? How should we produce these outputs? It simplifies things, and it shortens the amount of time between when the sales team decides what they want and how long it is until they get it.
So let's run through an example of this then. The procurement team is out there in the market looking for good product to run and turn into your product line. They buy 1,000 pounds of fresh frozen, 300 pounds of cured biomass. That goes into the extraction process. Out the other end comes what?
Pure THCa, and then a series of different HTE fractions from the different strains.
So there's two lots there, or two batches, and essentially you end up with one batch of THCa.
Yep.
And then you end up with a high terpene extract fraction, very small quantity, really easy to store, and then and that's just repeated again and again and again by the extraction team. Now the formulation team downstream of them has all these ingredients that are available to them. Maybe they communicate back to the procurement person saying, hey, we actually need more HTE from the live resin. Really, the only ingredient that has variability is the high terpene extract, isn't it?
That's right. Yeah, and that actually, really is conducive to extracting as much value as you can from the biomass too.
Right.
Right. When you're extracting just, in the traditional sense, just extracting live resin and then putting it out the door, sometimes you'll have more terpene fraction than you need, and really that's what's driving a lot of the value. So it can be very beneficial to run lower quality biomass to extract THCa, because it doesn't vary from strain to strain. That's just a molecule that you're after. And then you can, use the right amount of HTE with THCa from lower value biomass to get your potency up, and stretch that a lot further.
I guess the other advantage too is if you are in a pinch and you need more THCa, that is an ingredient that it's 99% THCa from anywhere you get it. It's always going to be exactly the same. So you have options. You can go procure the biomass. Maybe you get some low quality stuff if you're just after the THC. Or you can actually just buy kilos of THCa and use that in your formulations as well if you run low.
Yeah, exactly. It just depends on what products you're after and kind of how you're interacting with the supply chain.
So to me, the advantages here for extraction are really obvious. Doesn't matter whether you get fresh frozen biomass in the door or if you get cured biomass, your process is always the same. You extract, you isolate, you separate the THCa from the high terpene extract, and then from that process, the extractors are always bringing into the storeroom, those base ingredients. From the formulations and product manufacturing perspective, tell us a little bit about what that might look like.
Yeah, so from the formulations perspective, you end up being very nimble, and you end up being able to let the market, kind of dictate what products you're making, as opposed to letting the biomass dictate what products you're making. And so that's a lot faster, because you're not buying biomass in hopes that you can make, stable shatter or nice diamonds and sauce. You're just going to, your formulations team is just going into your inventory, grabbing the HTE and the amount of THCa that they want, and then making the product that are selling well.
And then your product manufacturing and formulations team might be communicating with the procurement team, but they're communicating in the sense of, this is how much isolate we're going to need, this is how much HTE fraction we're going to need, and it kind of simplifies the whole thing.
Yeah, absolutely. We also see a lot of situations where, if it's toll manufacturing or something like that, people, the supplier of the biomass will be requesting specific outputs, and that also becomes a lot easier.
Can you give me an example of that?
Yeah, so we had a client that was, doing a lot of toll processing, and the group that was supplying them with the biomass wanted specific outputs, and they were kind of stuck because they were limited how many products they could make based on what the input biomass was. And then by being able to split it into THCa and HTE, you gain a lot more control over, the stability of the carts, for instance, or, how much terpene fraction they add per cart.
The other advantage, especially when you're running fresh frozen biomass, is just how much high terpene extract that's produced in that process. And then if you're running, a whole bunch of other low quality biomass that produces high THCa content, you can then spread that out and kind of extend the value of your live resin runs.
Yeah, exactly. If you were just filling carts directly with crude, with a particularly, terpene rich live resin, you could be using, 4 times as much of the terpene fraction that you really need to use to get a desirable flavor profile. So you can stretch that a lot further by separating the THCa out and then, dividing that to a high terpene fraction over many, many more carts. You can get a lot more out of it.
What kind of equipment options are out there for doing live resin extractions and then doing the separation technique that we're talking about?
Yeah, for crystallization tech, I think that there's kind of 3 main avenues that people take. A few years ago, the most common was jars and Pyrex. You're allowing stuff to crystallize out.
I'd say it's still probably the most popular option.
Yeah, it's really low barrier to entry. The challenge is just that it doesn't scale very well. A room full of jars is pretty challenging, and then also it's not super safe. Using mason jars to fill with flammable solvent.
Yeah, one of our clients was using jars they were putting them in the oven and then using that for the decarb process. But in order to balance decarb with how much terps were being lost from the heat being applied, they could only actually decarb about 65% of the THCa into THC. And then it was always kind of balancing a fine line of whether the carts were actually going to crystal up when the consumer had them, or if they would be decarbed enough that it would be consumed right to the end without crystallizing.
Yeah, and it's challenging to run your business with that amount of unpredictability baked in. You just have a lot of curveballs that you otherwise wouldn't have.
And it kind of necessitates somebody who's kind of like this mad scientist, chief extraction guy that the business stops running without them and they can't go on vacation.
Yeah, exactly. SOPs get a lot harder to streamline, and that repeatability diminishes.
I guess that brings us to repeatability across states or countries, right? Because a lot of our clients now are looking at how do they develop a process that they can put into SOPs or videos and then have it done exactly the same way in every state they operate in, or in Canada or in other countries that they're operating in.
Yeah, exactly. A lot of the the multi-state operators, their biggest enemy is any sort of chaos or unpredictability, right? They're trying to meet these deadlines and meet their production goals, and yeah, you just can't have that uncertainty.
So jar tech being the first way. The next is really like using centrifuges, often along with jars. Tell us a little bit about that process.
Yeah. Whether your initial crystallization is in jars or diamond miners, the second way that people scale it up is you'll use a centrifuge to remove the high terpene extract from the crystals. So you'll let these crystals grow, and then you'll spin them out to be able to draw the liquids off them essentially, and perform a cleaner isolate, get a cleaner isolate that way.
Yeah, a lot of the time I think people are putting it, the crude, especially when it comes from live resin, it can crystal up pretty easily. So you put it in an oven, let it kind of form crystals. Then you take those crystals, you scoop them about 200-300 grams at a time into, or you take the entire concentrate and scoop that into these little baskets. Mm-hmm. And the baskets are I think they hold about 300 grams at a time.
Yeah.
And then of course oven space. How many labs have you been in where
it's a wall of vacuum ovens?
Yeah. You're lucky if you got one wall of vacuum ovens, yeah. Right? A lot of times our clients they have the wall of vacuum ovens and it's just not enough mm-hmm. to be able to continue to scale and hit their production targets.
Yeah, there's definitely a throughput limitation. You just can only spin so much at a time because of the weight balancing and stuff like that with centrifuges, and then like you mentioned, the ovens. The other thing that's challenging is again with predictability is that if you spin something out but it doesn't get super clean because the crystals were really small, as an example, you can't go and redissolve that very easily and perform that crystallization again. You're kind of you're limited in what you can do and how fast you can do it.
There's more variability baked into the process, mm-hmm. and then a lot more labor as well.
Yeah, exactly. Sometimes somebody will come to a jar and it'll be all one rock at the bottom, and sometimes it'll be a really fine sand. And yeah, getting that locked in is really challenging because there's a huge variation in how crude will behave depending on the biomass.
Training people to do that at scale is a huge challenge.
Yeah. Yeah, because you're training people, you know, a whole range of situations that they could encounter and how to react to them, which are always slightly changing, and trying to match that up with what you're trying to produce is really, really tough. The goal really, you know, with ingredient manufacturing is to do the same thing every single time.
So it's like the sugar refinery and then the bakery, two separate operations, but the bakery is, here's the recipe.
Yeah, exactly. If your goal is to make a marshmallow, and sometimes you've got, you know, beet juice, sometimes you've got molasses, sometimes you've got a big, massive sugar cube, you got a challenging workday.
Okay, so we've covered jar tech, some of the centrifuge techniques. Then there's just using diamond miners. A lot of our clients are using diamond miners. It's actually a good way to scale up from kind of the low, you know, the entry point to a little bit more of a commercial scale. Challenge obviously is growing crystals in diamond miners can take quite a bit of time.
Yeah, it takes a lot of time, and then it's also fairly difficult to clean the crystals from within the diamond miner. You know, they don't have filters involved. They can't go, you can't make them cold as easily. And so it can be just challenging to perform all of the steps required to get a really clean isolate consistently.
Especially when you're doing a lot of it.
Yeah.
And then, you know, we've seen similar situation with just rooms full of jars turns to rooms full of diamond miners by scaling up in that direction. And then you've got all these different batches that all have they're in different states. Yeah. And, you know, different states of progression through the process. And then it's kind of, you know, it becomes a challenge of labeling and keeping track of where everything is at.
Yeah, I mean, the diamond making process often will take, you know, a couple weeks to a month, and that can be very challenging, you know, logistically, to have that many batches, you know, in purgatory, so to speak,
simultaneously at different stages.
Yeah, but I mean, you can do some damage with a big room full of diamond miners.
Absolutely.
But you know, it's you know, it's somewhat of a commercial scale, but it's not an industrial process.
So that brings us to the crystallization reactor method. You can use a series of reactors, or you can use kind of a single reaction vessel to perform the crystallization there and control it. Do it at a bigger scale. 10 liters to 20 liters is a pretty standard range for that kind of a reaction process.
Yeah, exactly. You know, especially at this state of the industry, being able to do, you know, 20 to 40 kilograms in a day seems to be able to meet a lot of people's demand. But the reaction vessel technique really allows you to produce bulk isolate at an industrial scale, and it's proportionate to the size of your reaction vessel. But what we're using is the benefit that you can perform a crystallization almost, you know, the actual crystallization process is almost immediate with this fast crash technology. And so you can perform crystallizations over and over again, multiple crystallizations very quickly to produce a very pure isolate.
So what's the advantage of doing multiple crystallizations?
Well, crystallization, so it's essentially to increase purity and to remove variability from the process. So, you know, the first time you crystallize, often you'll have what's called entrainment, which just means that you're bringing some impurities along with that crystallization. When you do a second crystallization, there's a very small amount of entrainment on that second crystallization because you've already removed so many of those impurities, and it's only ever, you know, a small portion of the total impurities that gets brought back in.
So doing two crystallizations back to back, the output of that process, if that's your standard process, it's going to be almost identical, the THCa fraction that comes out of that 98 to 99.5% isolate repeatably with barely any variability.
Yeah, and even higher than that. I mean, really, if your first crystallization is somewhere between, you know, let's say on the very low end, 85%, all the way up to 95% on your first crystallization, that's a pretty big range. But once you get to the second crystallization, you're always, you know, almost always above 98%, just because there's so little impurities when you're going into that second crystallization. And crystallizing, you know, unlike distillation, it's a very clean, very precise process.
So back to speaking about the formulators must absolutely love that, because every single batch that they get is the exact same formulation. No need to recalculate THCa or THC percentages. you can then take that liquid, or pardon me, you can take that THC isolate as a powder form, melt that down, and make liquid diamonds. Tell me a little bit about what are liquid diamonds and how does that fit into the process?
Yeah, so liquid diamonds are essentially just decarboxylated THCa that was, isolated through a crystallization process. So you take these crystals, you heat them up, and you liquefy them into a very pure distillate.
So it's liquid THC isolate.
Yes, it's liquid THC isolate. Yeah, and also, liquid diamonds can be produced in fewer steps than a distillation process.
Well, and there's less waste as well when you make distillate. You end up with this. You end up with three fractions. The terpene fraction is essentially useless.
Mm-hmm.
Same with the residue fraction,
Mm-hmm.
and there's just so much work that goes into making that, and it's actually lower value in the end as well.
Yeah, I mean, you can, especially with white films, you can run three, distillations and only end up at 97% purity, and that's good enough for some applications. But if you can get to 99% purity
in one step
directly out of your, primary extraction, essentially,
yeah.
You're cutting out a whole bunch of post-processing and transport and logistics.
Well, I'd say the best part about that is how expensive is a two-stage white film evaporator.
Yeah,
like that is a very pricey machine. Often that's made in Germany, or these are high precision manufacturing
mm-hmm.
Systems, and a good quality one will run you about 500,000 new.
Mm-hmm. Yeah, and you can just eliminate that part of the process entirely.
Yeah, which is incredible.
Mm-hmm.
But when we're talking about live resin production, it really comes down to that terp fraction, and
mm-hmm.
that's the big advantage of this, is that now you're separating that out. You're making that liquid diamond fraction out of the THCa,
mm-hmm.
but while you're heating that up, THCa, it doesn't degrade when you heat it,
mm-hmm.
unless it oxidizes. So you do have to actually be, careful not to allow oxygen in the process, and to do that in a closed vessel. But the heat itself doesn't impact the THCa, and whereas with the terpene fraction, you really want to protect those terpenes from heat. So the beautiful part about separating them before any heat has been applied is that the terpenes are as pure and as reflective of what the grower grew as you can possibly get, especially when you're using a live resin or a fresh frozen biomass.
Mm-hmm. Yeah, if you've ever smelt the terpene fraction that's coming off the outlet of a white film, it's definitely not desirable. And so it's really nice to be able to conserve that terpene fraction, perform your decarboxylation step, and then, end up with a higher value product.
And then I guess the final thing that we mentioned that the consumer is looking for is no leaks. And if you're able to make a consistent, repeatable formula that will be the exact same viscosity every time, because it's just it's a recipe,
mm-hmm.
You can avoid that as well with this.
Yeah, exactly. You don't have those problematic, really high terpene fractions that can be a little bit more aggressive on the seals of the cart.
Or the viscosity and just kind of leaking through or whatever.
Yeah, exactly.
So what other sort of advantages are there to using a reactor over like Dartec, diamond miners, and centrifuges?
Yeah, I think the main thing that comes to mind is just being able to maneuver around unforeseen situations, right? So the crystallization vessel and its capacity to heat and cool allows you to try a second time if things don't go exactly the way that you anticipated.
Run me through what that might look like.
Yeah, so often when you're running biomass for the first time, especially as you get into lower cost biomass and whatnot, you have unpredictable situations that'll happen, right? Your crystallization will require you to be a little bit more concentrated than in other crystallizations, or you might have a presence of fats and waxes.
So in a really high terpene situation, like with fresh frozen biomass, how does that play out?
You might have to go a lot more concentrated before that crystallization is actually going to happen. And so with a crystallization vessel, you can attempt to do the crystallization, realize that, okay, I want to go a little bit more concentrated, and you can make that adjustment, go a little bit more concentrated, and try again. And then repeat that process for the rest of the lot, but you have the capacity to be able to make that decision over the course of an hour and adapt.
using a vessel, you can see into the process and be able to kind of make these judgment calls as well.
Yeah, it can be really challenging to fly blind essentially and not really know exactly what's going on. And so you have to, make a judgment call, or we'll have folks, if they're trying to crystallize in a column or something like that, you're kind of just, you're hoping that the crystallization is complete and then you're performing your wash. But really you could, you could either be taking way too long to do your crystallization, or it could be not quite done yet and you could be leaving THCa behind.
So really it's like a precision tool.
Yeah, it's you can perform an analysis while you're doing it, and you can make judgment calls based on more visual cues.
Any other notable advantages to making live resin carts using this technique, particularly the crystallization reactor?
There's an enormous amount of ease of use components to it, right? It seems sometimes like these wouldn't add up, but every time you go to pull a diamond miner off a shelf and open it up and lift it into something else, there's these product losses. It's hard for the operator to do and whatnot. If you compare that to them, putting a vessel underneath the bottom of a reaction vessel and opening a valve, it takes a fraction of the time, and that really does add up a lot over the course of a year.
Okay, so just to recap, give me a high-level process overview of going from biomass right to live resin carts.
Yeah, absolutely. So you would take fresh frozen biomass and you would load it into your extractor and perform your extraction with a 70-30 blend of butane propane at minus 40 degrees Celsius, as an example. Then you would take that crude, you would crystallize it into THCa and HDE.
So you can use either the kind of standard methods like an oven and centrifuge diamond miners, or a larger, more industrial tool like the controlled crystallization reactor, and that would be in line with your extraction process if you did it that way.
Yeah, exactly. Ideally by the time you're done your extraction and your crystallization, you're pouring isolate out of one part of the machine and HDE out of the other. Then you can decarboxylate your THCa, recombine it with the amount of HDE that is desirable to extend the value of the carts, make as many as possible, and then recombine them and then fill your carts.
Awesome. So that's by far the most scalable, repeatable, and consistent method that you can use to make sure your customers are getting the absolute best value from their live resin carts.
Yeah, that's right.
If you like this video and you want to learn more about how to put these processes into production, consider taking our controlled crystallization seminar. We cover every method for making THCa isolate discussed in this video, and we go in depth right here at the Genome Technology Center. So click the link below and join the waitlist today.